Good morning, everyone, and welcome to the next class. Our schedule today is already on the projector. We start with a guest lecture about Agile architecture and Agile documentation by Gerhard.Mueller. Thanks for being here. He's from the company TNG, a consulting company that has a very high focus on quality and on good relations to their customers. So I think you will get some insights on how Agile projects work in the industry field and how you can make sure, even in an Agile project, that you have a good architecture and a good documentation. After the break, we will talk about build and release management. The second part will be a large exercise again, where we do continuous delivery and feedback. And finally, we have the lecture evaluation by the university, where we hope that we got some good feedback by you. But I don't want to waste time, so I want to give over to Gerhard. You can start with your guest lecture. Thanks for being here.
Good morning. I made the title a little bit longer, Agile Methods and Practice, because I want to show you something that we do, and that's not only theory, but something that we really try to achieve. And I added release planning to the title because I think it's really an important topic, so that you understand where we are. So hopefully you are here. Yes. And to get a better understanding why I'm here and what is my background, that you can understand and relate what we are doing. TNG, Technology Consulting, is a IT consulting company that means that we help customers to create great products. And the company that I'm the founder, one of the founders of TNG, the next generation, the idea was to have a company where we are together in a way that we want to be, so that we are able to create things that are important for us and have a surrounding for us and for others to make professional work. And of course we are techies, so yeah. So this is our homepage. We solve hard IT problems. That's our motto. That's what we try to do. And we do that in Munich. We are not traveling around the world. We are doing that in Munich with customers from all sizes. We have a mind map, free mind map. That's our best marketing material that we have. So we are not marketing people. We are techies. That shows a little bit what we do. And the main thing we do is Agile software development when customers allow us to do. Sometimes there's a little bit waterfall-ish things in our projects. We don't want to have that, but it's the case. And that you get an understanding how many people we are. We are about 250 people currently. They are not all of them on a picture. We do regularly summer retreats, and this is a picture of one of the people last summer retreat, where we discuss things and what should happen in a company. So that's a little bit about me. I have studied computer science here at TU München, but not in Garching. When I studied, it was still Südbau with this nice asbest. That was a fun time. I also was part of the Fachschaft. So if you read the Impulsiv, I've been working on the Impulsiv as well. I've done quite a bit of Fachschaftswork, so to say. And yeah, so I'm a part of this university also. Well, it's a few years ago. I finished my studies to 1999. So if you are asking if we are hiring, yes, we do. We are looking for computer science people. There's probably a lot of companies. So if you want to join Yoda and our team, you're welcome, either as a Werkstudent or later probably as a full employee. So to give you an impression where we are living in and what is driving us, I want to show a little bit what is happening in the world so that you can relate why the other topics are important to me. It will be quick, but just to get an overview. Who of you still had a Nokia phone? And how many people still have a Nokia phone? Really? 2? Wow. but still there happened something in the world. So success in the past is probably not guaranteed if you have had success in the future. Or if you are using Netflix, yeah, there was a DVD renting company or Blockbuster. It was really famous in the US, but the model of how things work is not working anymore. They are bankrupt, and they had the chance to buy Netflix when it was still young and small. Therefore, it's really interesting how fast things can change, and if you're not prepared, you'll fail. So you need a good base for what you're doing. Or another thing, especially in Munich, Drive Now, for example, we have now services for products. So most of our employees don't have cars anymore. They use, for example, Drive Now and having the service of mobility, but not needing the product anymore. So things change, and also the company sizes change. So it was common that big companies were the only ones who had success, but now smaller companies, like for example, if you're using WhatsApp, it was about 50 people when they sold for several billions, and they reduced the revenue in the telecommunication market by several hundred billions for other companies. So it's a real huge success by technology and changing markets really fast. So yeah, being small, being fast is sometimes also an advantage and can really create interesting products. What often happens in larger companies nowadays is that you have some base systems, SAP, whatever, where the data for shipment, for logistics, for the contracts are stored, and you have to have a really thorough change process, test process, and so on. But on the other way, we have this changing markets. You have to try out new ideas. So there's a tension between this fast IT, where other processes are needed, where other kind of technologies are used than in the core IT, and you really need to have a good API or whatever to be able to connect between this core IT and this fast IT. So be prepared if you want to do exciting stuff where lots of things change, then you have to be in the fast IT, and if you want to have a stable environment with longer processes, with not so much change, then core IT in bigger companies might be something interesting. In the long run, of course, both is needed, and the fast IT parts of it that have success are incorporated in the core IT in the long run. So, but I want to concentrate a little bit more on the fast IT, so to say, where these agile methods have advantages. We are typically doing this in our projects either by doing innovation stuff, or if some important systems of our clients that were probably outsourced and the outsourcing company is having problems and so on, then we are called and we are helping our clients. In the last lecture, or one of the last lectures, you had a good understanding on the presentation of design thinking. I'm a big fan of design thinking, so I even created a group for it here in Munich, a meetup. So if you want to join, you're welcome. It's really something that is driving solutions in a way that they are more accessible to people, and have in mind that you have to work with other people with other backgrounds, and this is interesting, so be open to that. So when we have lots of change, you're probably used to classical project management stuff and so on, but that's not really working in a really fast changing environment. And so there's an important book called The Lean Startup by Eric Ries. It's not so old, 2011, and still it's the norm to use it, or the method that are presented there nowadays, because it's so important to have a good way to work in a changing environment. And the things that are combined in Lean Startup is customer development with agile software development. It's a really scientific approach, so like doing physics or some other classical ways of doing science, it's hypothesis driven, and you try to reduce the effort of learning. So you really try to learn as fast as possible. What is customer development? Customer development is something where you try to identify who will be your customers. And to be able to do that, you have to have a problem that is worth solving. So you really have to find the problem that it's worth solving. Because most of innovation ideas break down because it's not a technical problem solving it, but there's no need for it. So the most important thing to have is a good problem. And only then, if you have a good problem, you can find out if there's a market. And if there's a market, you're lucky. Then you can create structures and scale the company. But before that, try to be as small and fast as possible to maximize the learning process. Really famous in the Lean Startup community is this build, measure, learn cycle, where you try to minimize the learning time to understand if ideas are working. So you have an hypothesis, you try to, you have an idea, you build something, you measure, and if the measurements are sensible, then you have something learned. And if you try to create experiments, you're doing it the other way around. Normally, you have a hypothesis, you try to find up a metric, and if you have an indication when the metric will be at a certain scale, you know you have either succeeded or not, and you can then do the experiment to check this metric. So, helpful methods in this Lean Startup environment are this build faster, measure faster, learn faster things, lots of things that have to do something with software, with architecture. And we're going into a few things of that a little bit later. What I expect from you is that you have a good understanding of agile software development, like for example Scrum. I hope this is the case. Do all of you know a little bit of Scrum and what is related to that? Yes? Okay, very good. For me, important is Agile is not chaotic, it's really highly disciplined with highly small feedback loops, so learning is amplified. That's one of the ideas. It's getting quieter, that's helpful, thank you. So, if you have a fast changing world, what are the key messages? We live in a world with a lot of change, and IT is creating currently even more possibilities for new business models. Don't be too sure about requirements. They might only be a hypothesis. So question if someone tells you to implement something, if this is really something that is worth doing it. Markets are changing from products to services. Fast and first movers typically win. And high uncertainty requires a different thinking than classical waterfallish way of doing things. So have an interest in design thinking, Lean Startup methods, and Agile software development is part of these. So it's good to have a look if what these Agile methods and our experience with that provide as value for probably in a lot of cases. So when you start to do something, you need to have a thorough understanding how you come up with a plan. You come up with some hypothesis how big a problem is so that you can have a rough estimation how much effort is needed to solve something. And after that, I'll go a little bit into this software architecture that is necessary to support that. And we have all a great responsibility for creating something that is probably outliving us. So Agile documentation is something that is really needed and often neglected, and it's really a pity because a lot of work is done in product development, and often information is lost about what has happened, and that's really a pity. That shouldn't happen. So, understanding the big picture in product development, first is product versus project, and some examples then how to be able to understand the big picture and come up with the first idea of what you have to in front of you, what kind of beast you have when you want to try to solve something. The first thing that is often neglected also at university, but is really a huge difference, is if you're doing a product or if you're doing a project. A project has a defined end, typically, and it's only an endeavor for a certain amount with some people that are there for a limited amount of time. But what we're doing in the IT industry is typically we are creating products. We are creating something that is, at least in our company, is typically helping clients with IT systems that are necessary to support the processes in the companies. And as long as these companies are there, these processes will be there. So they have to be supported, they have to be increased. There's new business models, new ideas, new products, whatever. So we have to really create things that are living really, really long. For example, clients from the insurance side from us, they have systems that were created 30 years ago, and they have to go with them for an additionally about 70 years or something, because the BaFin requires that you can compute the tariffs on the systems that were used to create the contract. So it's really not so easy to help to do that, and we have a huge responsibility for the longer term stuff, and also the most effort will be there and not in the initial creation of something. So you should have a look at product management and not only project management, because even if we say we are doing a project, mostly it's a product. What also is probably not as easy to see at the beginning, you have to remove unnecessary features when you try to create a bigger product. Because if you don't, you will lose the control over what you have, because it's too big to be able to change anymore. And I've seen that at a lot of clients, and if you're not removing features or things of a product that are not needed anymore, it's really, really dangerous. I don't think it's easy to show at university, but if you are at bigger clients or companies where you have large software systems, something that is, if companies are not doing it, they are really swamped by the amount of code that no one knows if it's still needed or not, and you have to support and maintain them, and it's dangerous. So I expect that you know at least a bit about the business model canvas, so that you can understand how business models work. I think it was covered in other lectures already, so I don't have to go into details there. It's good if everyone in product development understands how things work, or what the hypotheses are currently about a certain business model, because only then this aligns people doing the right stuff, and you don't need so much communication because the vision is clear and how things have to work out. If you're really in a startup-like environment, or if you're in a bigger company doing innovation work, what you typically have at the beginning is lots of different possibilities how the business model could look like, and by experiments, by doing lots of work that identifies what is working and what not, you can eliminate most of the ideas how the business model is working. And you do that again and again, and at the end you have probably one of these business models that work out, and this should then be the foundation of what you're doing. This is not so easy, and in this time where you try to find out, you might have to support all kinds of different business models. So you have to eliminate the possibilities in this process when you have to support that with software. But the best idea is to write as least as you try to avoid writing too much software for doing that, because to maintain that all the time it's really difficult. So when you have an idea what to do, what are you doing then with this information? What we do in TNG is we are using a method called user story mapping. It was coined by Jeff Patton. It's a really cool guy. I've met him once here in Munich. He also, the ideas are from 2007, at least published by him about 2007, but has recently also created a book, User Story Mapping. And we use that very often, and it really helps to get a good understanding of a system or an endeavor, what to do and how big the effort is, and what the first sensible releases are. And I want to show that in a little bit more detail. So what we have is we gather all the stakeholders in one room and do some workshop kind of thing in about 1 day, and you get already a good overview what is happening there. I will go in a little bit more detail of this process. What you first think about is that you are creating personas. So you try to identify the most important user kinds that you expect in the system, which you have to support somehow for this product, and really try to create a fake thing where you say, this is the name, this is the picture, this is the age, this is the background of the person, and you really try to be able to have a fake person that you can relate with, where you can understand what are the needs of this person, how these persons work, where they work, the usage context of the system we are trying to create. So this is something that is really helpful, because an abstract role is not really helpful if you can say, as Anna, I would want to have this, then it's much better to relate with other people about the assumptions. This can be done in a day or something in a project. We had this where we really tried to understand a high-level view of a new business model, and this were the results. I had to blur them a little bit because of confidentiality. We identified much too many roles. In the typical good way, you need about 2, 3, up to 5 probably personas for a system, because they drive the most value, the most insights when you try to create something. So when you have these personas, the fake people that would use the system, you can really then have a look what are the main activities of these persons with your systems. So for example, if I have an iPhone, I can read email with an iPhone. So that's the activity email usage somehow. And you can, if you have a longer process, you really have some things where you can tell a story, how things start with probably onboarding, you do something, you order something, something is shipped. So these are the main activities that are supported by a system. And they are, so to say, on top and in a possible time way ordered. And if you're doing this, you can add the most important tasks that have to be available to do this. So to say, where you can really say, I have to this application or this kind of thing where that supports this activity. And of course, there might be several things that help you to do as a task, and therefore you get some stacked things where you have an OR thing where you can say, I do either this or that or that or that, and therefore you get a rough idea what the possibilities should be to work with the system. We do that, and it's good to do that on the floor because then it's easy to rearrange, or on large desks. You can rearrange them, and of course you can also prioritize. You can prioritize these feature cards, user story cards, depending how you're doing your requirements management. And when you order them, you can really have then also the idea of what should be in the system altogether. So the backbone is then the story that you tell, and with the essential activities. And if you want to have a minimal implementation, you have to support at least these essential activities somehow. You can of course fake a few things sometimes by manual work, but in the long run, in a more advanced version of your system, you probably need more. And when you go through these things with the users in mind, you can see which things are essential and which not. And you can really create sensible releases out of that just by being in the steps and in the shoes of these personas. You can say that makes sense and that not are the things fitting together. So we have done that several times in our company, and always had good results with 1 day of effort or something. So this is really going quick and is helpful. But still, you're not having an idea how big is this, what you have. It's just you have features, and you want to somehow understand what kind of beasts you have to solve from effort-wise. You should probably know planning poker cards. We are not doing typically in this planning poker because it's taking too much time when you would go through each of these tasks or user stories. But what we do is we put these planning poker cards on the floor and put the user stories just to the numbers. You say you have one item where you say this is number 3, and compared to that you estimate all the rest. And if you do that, you can do that in an hour, and you really have created a good idea which kind of user story feature is in which kind of bigness. And yet then, of course, you have to come somehow from this rough points of feature complexity, whatever. From these estimation points, you have to come to time somehow, and that's how we do it. We have a closer look at 2 to 5 of these user stories and try to break them down as far as possible, that you really have an idea, is it something that takes 5 days or 10 days or 11, and have an estimation wide from the minimum time to the maximum time, also discussing it a little bit with the team that's probably working on that. And then you say, of course, not everything will be in the extreme way, so it's not always the minimum, it's not always the maximum. There will be some statistics where things we will have advantage of statistics, and after that you have a rough guess from the minimum to maximum that seems reasonable from the current knowledge. And when we have done that in projects, typically after 2 to 3 sprints really working on implementing the stuff, you have some evidence, some real data, how much time you really needed for these story points that you have estimated. So, and if you go through the backlog again after 2 or 3 sprints, you have understood a lot more things about the system. And if you do that after that, we typically have a quite stable backlog for a certain time. So, I have already told that. Okay. What is, of course, something that you can't expect is that the velocity in sprints is always the same. So you have, after some working on some sprints, you have some minimum, some maximum, and of course this is something that will change over time. And I assume that the team that is working is stable, but you have a rough velocity of a team. Yeah? So when you're doing, do you know all release burn down charts, something like that? Because you have some in a release, you have some stories estimated with points, and after a story is really done, you can say I have earned some story some points, and you can say from the number of story points that we wanted to achieve, we have achieved some of them. And then it goes down, 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 if nothing is added to the sprint, to the release as new features. That happens. Yeah? Of course, that happens that things might be added, but in an optimum case, it's not the case. For this demonstration, it's not the case. And if you have the minimum, if everything works out perfectly, you might be ready here, or you might be ready here if everything is only worst case scenarios for the time from the estimations. So you have some release estimation, and you can of course project what will be in a release. Of course, you can also say we are starting with the most important features, the most important user stories, so that you will always have something ready when there's a certain date that was announced to customers doing this. A certain problem is that the knowledge about the future requirements is probably not so detailed as the ones that you are doing the next few sprints. So, and it doesn't also make sense to have a deep look into something in the future. There might be a lot of change in it. There might be a lot of uncertainty in it. And also what we have already discussed is that the world is changing. And it's not only the world, it's also the product development team that is learning. Stakeholders learn. When they see something, they have ideas, and it's good because these ideas might be really important. Competitors might create products that you have to, introduce features into products that you have to support somehow, or also copy them. There might be new technology, and so on and so on. So what is often happening is that you have a certain amount of change per month, per average, in products. And it's not in a fast-changing world. 5% perhaps of change is not something that is extremely uncommon. Yeah? And 5% change, when you're doing a little bit of math, I've tried to show it here a little bit, is something that has dramatic effects. Because what you do is you have a backlog with user stories, and we make easy assumptions. For example, we have 5% change, we have 10 story points velocity that we can achieve. In the first sprint, when you create something completely new, you would probably create something worth 10 story points. But in the second iteration, there was already change of 5%. What do? You have to create this change and work on the change. So it's not increasing the product, but it reduces the amount of velocity of story points that you can use to create new stuff. And if you're doing the math again and again, you will find out that that changing the existing system is taking more time. So you have less and less time to create new stuff. And that's also something that stakeholders sometimes don't understand, that at the beginning everything is working so fast and you have progress and everything, and then the team seems to slow down and not getting new features out as fast as in the early times of product development. So this is something that you have to manage. from the expectation view of customers, of stakeholders in a project. And at the end, in larger systems, you're just maintaining them all the time. There's not really new stuff that is you can create and add anymore. Is that somehow understandable, or should I go into more detail about that? Because there will be a question about that. Okay. So when you have sprints, what you have to do is you have to reserve, or say in the future, I won't be able to commit 100% of all velocity, of all story points that are possible to implement them, because there will be change that we will have to incorporate into the planning process. And if you add that, so you have to remove a certain amount more and more from future stories that you can commit. Because communication is important, and when you, for example, communicate a release plan, there will be things that will be in this release for sure. Yeah? If you take the minimum of all sprints with the velocity and so on, the chances are really high. If you only take this amount of story points that you can work on into account, you will probably be able to ship that. But then comes the danger zone. The danger zone is the area where you might be able to create and have something at the release date. You might also not. So can you communicate that without danger? No. You can communicate that probably inside a company or something, that this is a plan, we want to achieve that, but please don't communicate that to customers. Because they will then say, hey, you haven't created what you have promised, and that's a huge problem from their point of view if they expected that. And of course, the things that you won't make, probably you don't have to tell them anyway. And there's also another thing that we have seen often in projects, our product development, but especially for the first release, there's something what is not understood completely by stakeholders. When this is the velocity graph of projects, and we have done measurements in our projects and seen that again and again. It's not only theory; it's really we have seen that. At the beginning, the velocity of a team is not as high as later on, because you have you learn technology. The team is the people working together are getting a team. So there's a lot of you get faster and faster. After a certain amount of time, the velocity is then slowing down, especially at the end of the first release date, because you have to make things smoothly. There were things that the client or the stakeholders didn't tell you but expect from the system, and that's what we call dark matter. You need time for things that you didn't know about, and they were not for you communicated well, so they are new for you, but the stakeholder expect them anyway. Didn't you know that? And so on. That's really common to happen, especially at the first release. So the version 1.1 is always the most difficult version, because you have to clean a lot of small things up when first also customers then say, give feedback to you. Some pictures, not always from me, how this could look like with this user story mapping. So that can be done in the longer term, and often walls are better than the floor, because you have something where you can go to and point to and say, here we have to do something, so that these user story maps are getting information radiators, social objects in the product development. Another example how that could look like depends on how you do it, and but good walls are the ones that you are allowed to write on or have glass, so that it's easy to change things on. So, what are my key messages to Agile release planning? Think in products, not in projects. Understand the business model of the product you're working for. And if you can, really visit customers to understand also the people using a system. User story mapping is something that we have used extensively it's fast, it's useful. All stakeholders get a common understanding. If you don't get all stakeholders together in a room at the beginning of something, it's really difficult to fix that later. And planning into the future has to take uncertainty into account. So, software architecture. What is software architecture? There are lots of definitions. I think on the side from the CMU, where also Professor Brügge has worked, I think there are about 150 different definitions of software architecture. And of course, it has something to do with, you have some elements, you have some relationships between them, you have to define how that works. But in the long run, my definition would be software architecture defines the things that are hard to change. That's the definition of Martin Fowler. And if you look at in a certain way to that, it's the thing, what is difficult to change? Yeah, and where do you have to be right? How do you make the right decisions in an area where things have to be right? And it's not so easy. So what drives then software architecture? Software architecture, in our experience, is really driven by the entities of a system. So not the real normal feature usage, but the amount of people using it, the amount of reliability you need, all these things that are covered in this nice ISO 25010 generic software quality. And to understand which of these are the most important ones for your system, that is the challenge. So you need to have a good understanding of the market and the business model. We had a look at that. And only then you can make these trade-off decisions that are necessary to do something that is really working out in the long run. An example, not from software development, I've been on holiday in Italy and there was this really nice wine shop. And I thought, what a wonderful wine shop, lots of features in front of me, but somehow the foundation had a problem. Everywhere I saw these little cracks, and I saw something else. I saw that, a small change in the system and no cracks anymore. And hopefully you will be able to don't create a system where you have all these cracks, where you create problems for the environment, but where you really create something that is useful. So it doesn't matter which kind of features you have in a system, because if it would be water instead of wine or whatever, it wouldn't matter. Yeah? It's just not important. The important is how these features are used together, that creates the architecture of a system. That's of course only an analogy, but hopefully one that you understand. So what you need is to have a decision, and it's a really well thought decision, what is really important of these entities, of these non-functional requirements, quality attributes of the system, what is more important, and what are the things that are really important for that. And please try to work out these when you are in the role of doing software architecture. So when you're doing software architecture, what are the duties of a software architect? So he has to clarify these requirements, and not only the functional ones, but especially the quality attributes. And then people doing software architecture have to make decisions. They have to design the structures for the system so that all these competing requirements are somehow solved in a way that is working out for the system in the long run, and not only in the short run. And these not only, you also have to say in a product typically how error handling is working, validation, transaction management, whatever, how these things are working, and this has to be designed as well and communicated really well. Communication architecture is really challenging. You can of course create documentation in a written way, but this is only working to a certain extent. You have to good solutions that other copy. not probably with copy-paste, but from the ideas behind that. And of course, you have to be in the role of a software architect. You really have to clarify things for other people. There's a nice comic about that. You probably have seen that. So even if everyone's saying we agree on something, it doesn't have to be the way it is. You really have to often make it more clearer than others expected to make clear. Only then people get a really common understanding and the same common understanding of how things should work in a larger systems. So you have also to communicate the vision of the architecture, and it's really not easy. What helps creating software architectures are a lot of small things that you do again and again. For example, you work bottom up, you understand what other frameworks and libraries are doing. You work top down to be able to create certain structures. You know about domain-driven design. You have different views, different patterns, different styles, and so on. And all that you do again and again, and working with the system and working with the people, you're forming something that is really, in the long run, the base of the product you're working on. So some examples of architectural styles and patterns. For example, one of the things that you see again and again is this, for example, this layering, technical layering of a system. So you have layers or other thing that is often used, for example, also in Unix, pipes and filters, you probably know that. And also model view controller is also an architecture style that you see again and again, and there are of course more of them, but you should know these kind of architecture styles and find the right one for the problems in front of you. So what is then a good architecture? A good architecture is a system where all these constraints that there are solved in a way that helps and allows you to, in the long-term evolution of a system, and not only the current problems that you have, and also it has to be sensible from a business point of view. There's a lot of effort put into the systems you work on, and you want to make sure that they are valuable also in the future. And you don't want to have a system that is has to be abandoned after 3 to 5 years because no one can work on a system anymore. And I have seen that. I have seen systems where people were working on a system for 3 years and they were not able to maintain them anymore because they didn't create enough structure and didn't work so well. And after that, no one wanted to support the system anymore because it was so hard. And that shouldn't happen. So size matters. Yeah? Size of a system. We typically work on systems that have about at least 1 million lines of code, probably a history of 5 years, 7 years, whatever. There are lots of people working on a system. The largest project at TNG we're currently working on has about 100 people and 70 of them are from us. So it's also the question how long the self-organization that Agile promotes. When you have a look at the Agile values, it's not so clear if you can self-organize 100 people. And of course, communication in larger projects is quadratic, n times n minus 1 in half. So if you are not reducing this theoretical communication disaster, so to say, you will get into trouble. Yeah? You will only communicate in a product development, but not resolve anything anymore. So you really have to think about that. And also when you have a look at how much time you use for what kind of activity in larger projects, it's about 70% is code comprehension. 70%. That's where you can work on. That's where you can create a difference when you have good structures. So that this amount of time is reduced, and only 20% is problem solving and 10% really writing code. So for me, the argument of having efficient code writing, the number of letters you have to type, is for me not really something that I look at. I want to have something that is understandable when you read it without too many side effects. So typically easier languages are better for that in the long run. So you have something like a big system, and you need to have some structures that make it traversable in log n time instead of going through the whole system and you have to read everything. Think like a newspaper. A newspaper has a headline, it's an abstract, and then is the real deal, the main article. And we have to create these kind of structures and ideas also in software, that we don't have to read everything in every line. We have to have a good mechanism to come to the point in a larger system where we want to change something. So what are the possible cognitive models that we have as a human to do it? One is chunking, so things that are similar, that you chunk them together. The other thing is hierarchies. For example, this layering of the technical layering of systems is one of these. Or you create schemata, so you have a certain role of something again and again. I'll come to that in a point. And what we can do is then modularity, layering, and we create patterns. So it's something that you really should know. Pattern languages where you say this class is working with other classes in a certain type, it has a certain role. So these kind of, and yet you shouldn't have all options for that. You should concentrate on the most important ones and the most common ones, and that really helps to create a well-formed architecture that other people can relate to and understand. And also, if they're working on another area of the system, they are able to work there because they understand the common characteristics of the system. So these are in the bottom, you see what is typically done in computer science to help to do that. For example, modularity with interfaces and coupling and so on. It's probably, you heard all of that. You should really try to do that when the system is getting larger, to concentrate on these kind of things. I would say at about 50,000 lines of code, you really have to start thinking about these terms to be able to structure a system. Something that you probably not heard too often is what kind of hierarchies are more important. It's always a discussion if you're doing more layering or more domain, more technical layering or more domain layering. For me, in larger systems, the domain layering is more important. So the business area where you're working on is more important than the technical details layering of these areas. So always think of domain layering first and then the technical layering when you create structures, for example, package hierarchies in Java or whatever. When you do that, always start from the business point of view and say this is the ordering system and this is the distribution system, and then go into the technical details how this system is then technically layered. So, for example, creating Java package models is the way where you can do it. So, where is software architecture mostly done in the Agile world? In a team in one team, you typically have something like as a sprint 0, or you are thinking about that before even the project team is coming together. And then a lot of things happen in sprint planning because there you typically create and discuss the high-level way of doing things. When you have more teams, it gets more complicated. Of course, you can have something like a common community of practice where you from all teams have someone who is responsible for architecture stuff, overall stuff. But you have this trade-off. Is it something where emergent design is coming up and you think this is the right way to do it? Or is it something that you really have to think deeply before you're doing it, and it's not so clear where these trade-offs are? Sometimes you will see that you need to give more structure and to do it more formally, and sometimes it's better to just wait and see and the emergent design of the system comes out. But the larger the project teams, the more you have to think before, and the more it gets dangerous and difficult. So the role of software architect is, we typically don't say in a project we have a software architect. We have experienced developers, and that's enough. But when you have bigger product development teams, you have this agents in teams that work together on the architecture, or you have at a certain size really architects that support the other teams and fit things, help letting things fitting together. And often software architects are not only working on normal features, but also they have to be able to work with people from user experience, for example, or from business, because there a lot of trade-offs have to be made. And this is something that shouldn't happen. But this happens in large projects. It's not made up really. Because you have problems and you can solve them in different ways, and you want to have in larger systems one way of doing it. Is it readable? Yeah. So, what are larger frameworks of software development saying to this? Of course, for example, Scaled Agile framework has something here, Agile architecture, or when you have a look at less, it's another way of doing large projects, large product development efforts. Then you have here this architecture and design, where these things are made clear how that works in larger product development efforts. So, what you do, you have to work on the large structures, but also on the small structures. Craftsmanship matters. If you're making the system better every day, a small bit, you will get a much better system. If you make it worse a bit every day, you will make it much worse. So start with clean code. Know your design thinking patterns. Know probably domain-driven design if that is something that is working in your area. This is the basis, the foundation where you want to have a common vocabulary. I don't want to go into the details. It's just you have something like a factory, value objects, entities, services, whatever. So you have a common vocabulary of how things work together in your system. And then hopefully you're more on the left side than on the right side in the long run. Probably known this small comic. So how do you make decisions when these decisions are so dangerous and important? You should create options and test them. So you should make some spikes when you're doing in product development in a Scrum team. Give someone a few days and have a look at it. And someone else also some days and also have a look at it. And then you know more. And you should delay decisions as long as possible, but not too long, of course. When you have to make the decision, you have to make the decision and not waiting. And try to make reversible decisions. Yeah? Sometimes a small interface is something that really helps, because then you might be able to separate something and create a different solution. And of course, create the architectural decisions really well. If you don't, other people won't know and they will create their own ideas. What are architectural decisions? So these are strategic decisions where you have things that span several subsystems, or you have to really heavy compromises, trade-offs, intensive stakeholder discussions, political stuff going on, and yeah. And also, you can test architecture. It's really common nowadays, at least in our company, to write unit tests and story tests and whatever. But architecture testing is not something that I see very often at clients. And you should, because software architecture is the foundation, so you should test it. Something that is really good known for that is ATAM. Probably it's told already, I don't know. But this is something you should have a look. And of course, there are also commercial tools to help to understand if the structure is still the way you thought about it, and so on. But from time to time, a manual review of the architecture really makes sense. And after that, you should also, as a software architect or in a role of a software architect, you should know that you have to create a system that is easy to change, where this is part of the design of the system, that it's easy to change. For example, continuous integration deliveries should be something that you really integrate into the architecture, that it's possible to do that from the beginning. And I think you're working and demonstrating this not with Jenkins but with Babu, but in principle they are all the same. We are using both. I have good experience with them, but that you should do something like that from the beginning. So the key messages of continuous architecture: architect products, not just solutions for projects. Focus on the quality attributes, not on functional requirements. Delay design decisions or architecture decisions until they are absolutely necessary, so that you have the most options. And you have to take into account that you architect for change, so that you have lots of smaller pieces that work together somehow. If you heard about microservices, this is the way to go. Architect for build, test, and deploy, that you can do that really easy. And of course, you have to remember Conway's law that you probably heard also somewhere else. Model the organization after design of the system and not vice versa. Otherwise, it will happen if you have three groups of people and they should write a compiler, you will have a three-pass compiler, independent of if it's making sense or not. Last block, Agile documentation. And this is not Agile documentation. It's not enough to have code. Some people say code is enough, but it's not. You need overview. You need something what is a little bit more structured. But before that, I want to go into the physical tooling, because that's something that is often neglected. You need to have a working environment where you can document what you're working on. And then a little bit of separate software generating documentation and enhancing the product. So, who has seen something of that in your life? Has everyone read it? I have another one. This is also funny. And of course 42. You know, 42 is always the answer. So what I try to concentrate on, if starting with the physical environment, to be able to document what you're working on. So whiteboards in rooms are important, and it's not an excuse to say I have no whiteboards, because we have magic charts. Magic charts are just some plastic foil that you can put on windows, etc., and you can write on them and put them somewhere else easily. If you even don't have the chance of using them, you could have foam boards where you create large walls in a matter of minutes or seconds, where you can create information space very easily, and foam boards are really not expensive. This costs about 20 euros or something, and it's not heavy. You can stack them and work together. Then, of course, when you're doing something, for example, on a whiteboard or foam board or whatever, you can have your mobile phone and use it to make pictures of the whiteboard and put it in a wiki or somewhere else. So you can document what you're working on and share that with others. Or what we have here is a video camera that will videotape everything what I say, and then make some documentation about, for example, when someone introduces a part of the system, that you can use them later. And making videos nowadays is really easy, really easy. Or you should have an HD beamer in every room where you work together, because then you have the possibility to look at code together, and then you have the common knowledge with the code in front of you, or some other models that you're working on, where you can show a larger group of people how you work together. You can make a code review together. You should really have an HD beamer in every room. And when you have that, you can, for example, make small sketches of how you think things should work, and you have this kind of small sketches for the whole sprint hanging on the walls, So there are information radiators where you can look at, where you can relate to all the time. And of course, this tooling. I'm a big fan of Confluence from Atlassian that you probably use also here, so very good. And I'm also one of the founders of the Atlassian user group here in Munich. If you want to join, the next meetup will be on the 13th of July. So if you want to see me again as a moderator, come and see me. We have interesting talks. And what I find so interesting about wikis is that they reduce the amount of effort to change something. And if you don't have a document of someone else, it's a huge mental barrier to change something in a document of someone else. And that doesn't happen in a wiki. And if you're creating sketches also from UML, there are plugins for that where you can work on code, so to say, and still have some visual representation. But the changes you do, they are difficult because they are text, yeah? And that makes it much easier to work together. Also, if you have something like some visual stuff in your project that is quite common, having something like Balsamiq also in a wiki where you can have a look at sketches, how these things should look like, especially if you are working remotely, it really makes a difference to have something like that. And also what helps is to have a common understanding, especially in larger companies, how to document something. What kind of things should be documented, to have some guidelines. There are lots of people saying what should be done. What I have found really helpful is this ARC42 template. The ARC42 template is written by Gerhard.Mueller and Peter Ruschke, two German guys, quite famous in a certain way, and they promote a structure where different kind of things are shown, and you fill them out. You have a small template, so to say, that can grow for your requirements, that can grow from your needs. And where you say you have this requirements-related information, the structure-related information, the concepts, architecture and design decisions in a way that makes sense. So if you want to try to do it, I think the ARC42 template is a good start of working on the documentation of a product and really makes sense. What we also found out that in our project that we do, often in larger companies, the so-called Fachbereich, so the people that have the domain knowledge, they are not really good at documentation, especially small details. So what we have created is an open source project, jgiven.org, where you are able to write code, and then the documentation is really created from this Java code, and it's readable, at least by the domain experts. And it's because it's part of the continuous integration and delivery pipeline, you can be quite sure that it will be current. It can't get out of sync from the code. And I think this is really helpful. And then you have something that is living longer from a documentation point of view as when you just write, for example, Word documents. Don't do that. Another idea that I find really interesting and that we try to incorporate in most of the projects we have is something like Swagger. Swagger is an open source API library that you can put into your systems, and if you have interfaces, for example, JSON REST interfaces, you can make the API explorable by just adding this to your product in a certain way, and then you can really try out your APIs directly from the product. So this is a pet store example, and if you want to try it out, then you can do that on the website. It's not something that is hidden somewhere. You can really put something in certain input fields, press on do it, and then you just have the results and you see what the results are. So I think this kind of of thinking that you try to make documentation as easy as possible and as fast as possible is really something that you shouldn't neglect when you do when you're doing project work, product work. So overview documentation is really important. It helps from the pyramid of log n, the first parts, you need something different than code. So create overview documentation, use, for example, arc42 as template, capture low-tech information with your iPhone, whatever, and put it in a wiki. It's often enough. Try to integrate self-documenting features into software. And if you want to have a longer talk on that, I've just given a talk a few weeks ago here at the Gesellschaft für Informatik Regionalgruppe München, and have a look at 1.5 hours about Agile documentation. What should you remember from today? In a fast-changing world, Agile methods provide a valuable toolset, and I've shown some examples. Think in products, not in projects. It's really important for me. Agile estimation and planning of products is possible in really short time frames, for example, with user story mapping. Software architecture is important. Don't create too many cracks in the world. Make something valuable in the future, and documentation enables us to transfer knowledge in the future. And as we have lots of responsibility for that, that's something we should try. So still, your plan is probably easy. Reality is a little bit more bumpy. And of course, there shouldn't be a talk without cats. Deadline is coming, so be quick or be dead. So, and I don't know if you have time for questions and answers, but that was the end of my talk. Thank you for your attention. And in time, I would say.
I think we have time for 1 or 2 questions, so if any one of you has some urgent questions, please go ahead.
Too many slides and not enough time. Haha.
Okay.
Ah, there is one. My turn.
If there is a wiki and it's quite full of information, how to avoid that this information gets abandoned and is not improved anymore if the system evolves?
Important question and not easy to answer question. What I would suppose that you have a doctator in your team, someone who is a dictator, but also for documentation has a overall general idea what should be there and what not. What we do in our company is that we have certain days where all of the people go through the wiki and try to identify outdated, false information and remove it. Or if you find something in between, just put a label on it like obsolete, and we have people with a lot of knowledge that go through this obsolete stuff and try to either kill or update the stuff. And also what you can do, and what is, for example, Atlassian also doing, is to have some doku sprints, so 3 days sometimes, where you try to improve your overall coverage, where you really concentrate on documentation and nothing else. That's something that helps, and of course in the definition of done, you have some checklists how documentation should look like. And yeah, but still it's not easy and it's always an effort, but what are better solutions? It's not so easy. Does it help? Okay, thank you. Good question. Can he get some additional points somehow? Maybe.
Okay, thank you very much, Gerhard, for this nice guest lecture about Agile documentation, architecture, and some more best practices. If you have more questions, please come down and during the break. So we will have a 15 minutes break now, and we start over at about 10 with the continuous delivery exercise.
And you can write me emails, no problem. I will try to answer them. Or come to one of the Atlassian user group, design thinking or whatever. Would be a pleasure.